Welcome to Visualizing Research Data. I am Lily Popova Zhuhadar, Associate Professor of Analytics and IS. In this workshop, I am going to introduce the history of visualization, just very brief, then a concept that is really important to understand, which is the pre-attentive attributes. Then I'm gonna introduce you to some basic charts and some charts that are problematic to use and give you some warning about them. And finally, some contrast and comparison. I have to make a disclaimer here that most of these slides in these workshops are coming from two sources. The Tableau training workshops for faculty, and the second one is from the big book of dashboards. I'm gonna start with that. And first of all, let us start with something very interesting. Does anyone know what this is? It is a stained glass window, but do you know actually where it is located? It is in Kentucky, so to give you some hint. So it is in Covington, Kentucky. This is the Cathedral Basilica. And it could be one of you having a research about a comparison of stained glasses in different churches. And that could be a data point. Why not? So how can you save the data and in tables if you have hundreds of those type of stained glasses and you're doing a comparison analysis and trying to see how many colors been used, what style been used, and the years and the history and the type, and link it to the the church and many other type of information. So yes, this is data. So let us move to this data set and ask you the following question. Can you count how many times number 7 appears in this data set? Please write your answer in the chat area. How about if I make very simple change? So is it easier now? So we simply change the color of 7. You can change your answer if you want. How about if I make it bold or underline? So yes, we can do all sorts of things to make the 7 easier to see. So what we are doing here is using what is called pre-attentive attributes. So things like color, size, orientation, and texture are pre-attentive. It means the brain processes the information prior to focusing attention on anything. It happens in about 250 milliseconds. This is how quick. So the pre-attentive attribute is well described in the book, the big book of dashboards. And I'm borrowing this screenshot from that book because it really emphasizes most of the things that you can use in your poster when you want to emphasize specific finding, conclusion in your research that you want to tell the judge about. So you can use the length, the width, the size, you can shape, orientation, enclosure, grouping stuff, positioning, coloring, and etc. So those are the things you can use to help your audience spot immediately your finding. I know you worked so hard on your research. I know you spent days and nights, and you might went to the Warren River, collected samples from the river, went to the lab and you tested the pollution in the river, or you did some type of experiment in the chemistry lab, or you might be worked on some historical paper in the library. You did all the work and you spent so much time. So why not using the pre-attentive attribute to help your judges see this information easily? So this is what we're gonna take advantage of today. Another thing, order is really powerful. We can take advantage of the order to present our data. So by ordering this data, we can now see that there is exactly one row of data. We now have information about this data that we did not have before. We are turning this data into information. Now, because the rest of the data is not important anymore, why not turn it from black to gray? In this way, you are emphasizing the blue. You are emphasizing your finding. So try to, take knowledge from here, emphasize it on the visualization in your poster. Now, what else? We can use charts to visualize our data, and now we have more information about this data set. But just as we order the numbers in the grid on the right side, we can do the same on the graph, correct? By ordering our graph, now we have even more information that we can use. For example, we can see now that the 7 are on the third from the bottom. We can answer questions like what are the top 3, or what are the bottom 3, or what is the second most. These are very easy to see and answer quickly and accurately from the graph. Also notice how easy it is to see the 6 that shows up just one more time than the 4. So even very small differences are easy to see from the bar chart. That's why I like the bar chart a lot, and it gives you really vivid information and quick information. Now, the same information we had there, I just turn it to pie charts. And as you can see, the same information. Can you find what happened here to number 7? Compare it here. How much easy it was to find that number 7 appears 17 times and to compare it with the rest. Pie charts are not easy to use when you are trying to compare between numbers or between categories or between things that happening. And I'm gonna give you warning from here, and later on, if you are insisting on using pie charts, I will give you some things to do to consider when you are trying to use them. Okay, so let us move. Okay, so in general, when we have data, we can turn data to information. These are questions that we can ask for, which is similar to how many, how much type of questions. Example, how many computers do we have in the factory, or how much were sales last month? When we move from information to knowledge, these are why questions. Okay, so the how many, how much questions are usually easy to answer, correct? We can go to our database and write queries such as select the count of computers from the inventory table, and where the for example state is Kentucky, and in the database we return how many computers were in Kentucky. Okay, so but try to ask the database by maybe typing select what the reason for our sales to go low last month. That's difficult, that's a difficult question for your database to answer that question. So how do we, or how do we increase sales? How do we decrease expenses? How do we lower the defect rate? Data visualization is terrific for the how much question. And if we do it well, we can often answer the why questions. So it's up to the human being now to interpret the information and apply strategy to answer how do questions. Okay, that's where your role is. I have to start just quick history that now we know what data visualization is all about and how it can help us. Let me introduce you quick history about the data visualization. Data visualization is not a new domain. It started a long time ago, from the second century. Actually, Claudius Ptolemy introduced the tables, as you can see on the right side. Almagest book, you can see it's written in the Greek. Tables were there from the beginning. So yes, we used data visualization a long time ago. To give you credit after that, I'm not gonna go in details into every philosopher, historian, statistician who embedded data visualization and brought us to today. However, I have to give some credit to people who really demarked our visualization field, really amid their claim and their stamp into this field. So one of them is René Descartes, who really, if you recall his popular saying, I think, therefore I am. So who introduced the Cartesian coordination systems. I will have to give a credit also to another French theorist, Jacques Bertrand, for his really association with the perception. And I'm going to give you a couple of examples to understand how our brain function and how the brain can really impact our view of visualization and how can play tricks on us. In a couple of games, in a couple of slides are coming soon. So the visual perception, a lot of experiments he had done in the past, and a lot of theories built based on a lot of publications in simology graphics, that the field that he was very knowledgeable in. Then, of course, we have to mention John Tukey, which is our American statistician who worked in the Bell Labs, and he developed and wrote the explanatory data analysis, the EDA. The ADA, which is one of the foundation in the American history in statistics. He advocated to show that the visual manner as an easy way of understanding of statistic and the need of statistical models and hypotheses. He invented the box plot, and also he's known for the box and the whiskers plot. And he wrote about the plot and the bag plot, if you heard of him. Also violin plot, if you never heard about that. And there are another two I have to mention. Edward Tufte, definitely. So he was one of the earlier authors of the data visualization, and his book, The Visual Display of Quantitative Information, it's a rich book of data visualization. He's the one who invented the sparkling that you see always in the stock market. You have the visualization here. I have to give him the credit as well, and he will be mentioned a lot in this slide. In this workshop. Also, William Cleveland, who another very important author in the field of data visualization. His early book, couple of books actually, were the foundational and the building blocks of data visualization. He studied how people perceive information, and his studies they are pivotal in the research and he's often cited to create cited for creating the best practices in data visualization. So he is really very known for being a practitioner in data visualization. So let us just convince you a little bit with some of the concept of how the brain can play tricks on you. So we're gonna start with some video brain games, okay? So the image here was created by Dr. Bo Lato of Lato Labs. So this is an object that appears that is gray on the top and white at the bottom, okay? So this is how we see it. This is how our brain sees this image. However, I'm going to try to convince you that those two blocks are exactly the same color. Those are exactly the same color. There is no trick here, but this is how our brain reflect based on the background. So to convince you, I have to do the following. Okay, so this is how our brain, reflects to see images based on the surrounding of other colors. So let us have another example. In this example, the bar appears to be going from light gray on the left to dark gray on the right, correct? But actually, this bar has the same color. Only because the background is gradient is causing our brain to think that this is a gradient. So let me show you how this is one color. Okay. Let me ask you the following question. How many colors do you see? Do you see two? Light blue to the left and dark blue to the right? Actually, there are four. Okay. This effect, the moiré effect, is really important because I notice a lot of our students in their presentations, when they use charts, use the grid line with their charts, and they cause that effect, moiré effect. And I'm trying to convince you how you can improve your charts by either remove those grids or improving them in some way. So what does the moiré effect? It creates some type of shimmer. And what happens when you stare on this longer period of time, so try to stare on this image longer time, after a while you can start feeling like there's a movement. And more happens when you have more than one effect. It gets worse when the grid is one on top of the other. So here is what my recommendation is. So we can see in this data visualization, the grid line and bar chart this is typical example in most of the posters that in competitions or even on the PowerPoint presentations students present them. So in the top, the grid line are dark and narrowly spaced in increment of 50. So notice how the grid line get in the way of the visualization. So you cannot really see the thread line that you are trying to emphasize to your audience, to your judges. Where in the bottom, the grid line is grayed out and it's wider, and it's incremented by 200. And how the same chart so easily to interpret and to see. Again, the upper one, moiré effect, really causing our brain to not see the trend easily, where the lower one, easily you can see it and you can emphasize it. Again, another example of moiré effect occur here because you have too many bars. So the advice would be just pick top 10 or top 5 or top 4, don't add so many, people are not good in adding too many information. Another thing that I would like you to pay attention to, and this is what our brain tries to play tricks on us, try to stare at this black dot about 15 seconds. What's happening here is the brain is processing this information. But after a short period of time, this image is going to be embedded in your brain. So technically the brain operates on a very small amount of energy, and so it has to work efficiently. And basically it says, okay, I got it, we need to keep processing the same information. So now if I move to the second image, you will see for a couple of seconds that it was colored. However, the image was not. It was just black and white image, but appeared at the beginning to be colored because the brain has a previous slide in the memory with color. Okay, let's do it one more time and then we move to some serious stuff. Okay, stare at the red dot this time. The woman knows. Just 15 seconds. Now I'm not going to show you any picture after that at all, just you're going to see a white page, blank screen. However, you're going to see a ghost. And by the end of this workshop, you're going to go and tell your friend that what you learned in this workshop is you were able to see a ghost. Did you see it? By the way, this session is recorded, so if you didn't see it, you can repeat it later on. So we are recording this session in a way that students can see it later on, because we know the timing is not perfect for everyone. Okay, so let us move now to the second section, which is the building block of data visualization. We learned, and according to Bertin, that we have to consider using shape, orientation, color, texture, value, size, just to enhance our representation of data. Okay. On the other hand, from the big book of the dashboard, Jeffrey Schaffer advised us that we always try to have your presentation or your chart to be clean, to be clear, to be concise, and captivate. So don't overdo your stuff, okay? So let us start with what are those type of charts we're talking about. You can use, if you have data represented in table, you can use colored highlighted table to emphasize the data. So here you can see pop up quickly if the importance here to show the cells. So you can see here the darker is maybe more important. So the 100,000 immediately appeared here and followed by 98,000, etc. Okay. Another type of charts, the dot plot, and the dot plot are, it uses position to show a comparison. This can be, from a common baseline, or can show the dot without a common baseline to show position from each other. Okay, so and that's one of the oldest way to show the information. Of course, the box plot was invented, as we said, by Jean Tocquy. And it's used a lot, and if you are using it inside your PowerPoint presentation or your dashboard, you have to understand the meaning of each part of it. So the box plot, it aggregates and summarizes the data. So it typically shows the 25th and 75th percentiles, or the 1.5 IQR. So it's not critical to understand how to calculate this, since most visualization software will calculate these for you. But since you have to represent them, you have to show what they mean. There's a better way. Another way to take advantage of the box plot is to use the pre-attentive attribute, as we said. So by positioning the primary comparison, because this will be really important for your audience to understand. So the box plot does not need to have axes that start at 0, so it's not like the bar chart, and can be rotated vertically or horizontally. You can do whatever you want with it. Also, the box plot may not be the easiest thing for the reader to understand, so sometimes you can add to it, to make another relationship by adding probability density function, for example. That could be helpful. Another type of chart, the histograms. Histograms uses the height to show the distribution of data. The bars are typically plotted close to each other and is typically rotated. And any software can give you that automatically. You just select your data, and now Excel give you recommendation even, and other tools automatically will do this on your behalf. Just you need to understand the meaning and what you're doing with this data. Now, bullet graph are extension of your visualization and started to appear a lot in recent years, and they are excellent way to show an actual value compared to a target value. It uses height or length from a common baseline for the actual value and position to make the comparison to the target line. Color can be used to show performance band, and the actual value can be shown in context to the desired performance levels. More, you can, for example, here the blue bar in this bullet chart represent the actual value, and the black line here shows the target for the number. It is easy to see exactly where the actual value is compared to the target value. The shaded area represent performance bands, darker gray for bad, or medium gray for satisfactory, and the light gray for good. We know immediately the light gray is good because this is the area on the chart where the target line is, but not the target line could also be reversed. Okay, so showing lower is better. For example, the target would be set lower for defected or expenses. Another thing, bullet charts are native in many applications now. For example, in Tableau it is native. Now for Excel, historically I recall that I was able to download it as add-ins, and you can, if it comes with the newest version, I'm not sure, but you can look at Excel add-in function if it's not coming automatically. And if you have questions, let me know. I can find some add-in. Always, if there is someone who will be adding more plugins for those type of applications. Okay, stacked bar chart are very important, and divergent bar chart as well. So a divergent bar chart uses height or length from a baseline with the bars diverging from the center. It provides precise quantitative comparison for each diverging segment. For example, here the blue bars compare to each other, but at the same time allows a relative comparison of the segment as well. For example, the blue bars versus the gray bars. The stacked bar chart uses height or length from the common baseline with another bar plotted on top of it. Color is used to differentiate the bars from each other and allow for relative comparison. Notice that the bar on the bottom, the blue bar in this case, allow for a precise comparison, but the gray bars do not. Next, the sparkline, which have been seen a lot in recent years with Excel, with Tableau, with many other applications. Sparklines uses position, and spark bars uses height or length to encode data. They are small, word-sized graphics that add context to numbers. They can be useful to show trends in the data in very small space. Line charts encoded data using position and is a good chart to show trends over time. It is best to keep the time series on the x-axis, not rotating, and having the oldest time period on the left going to the newest time period to the right. Those are the recommendations. Now the heat map encoded data using color to highlight the difference in table without using numbers. So for example, if in your coding here, orange closer to the red, so it's more alerting, and the blue is positive, closer to the green, which is good. So if this data represents cells, so if there's the decrease in cells, so the orange will be alerting for you that there are decrease in cells, so you really automatically will spot where the cells are decreasing in this case. Scatter plot uses position to show the relationship between two variables. Typically, measures are plotted on quantitative scale, and additional measure can be encoded using size. Now, Gantt charts, they use length and height and positions to show when one thing ends and another begins. The slope graph, those are very popular in recent years, uses position to quantitative comparisons or rank, typically between two times period. I will give you examples so you can understand it better. So here, for example, slope graph can be very useful chart to show the trend in two different time periods. Here it is like the sales by state, 2014 and 2015. So as you can see, for example, the blue one in Washington we are comparing, the sales was very low in 2014, about 25K. Then in 2015 it jumped almost about I would say 60K. Okay, so very easy, quickly you can see this information. Also, funnier and better way to see it, here we can see that we can use it actually to look at the comparison, predict versus actual wins of the NFL football team. And this visualization created by Andy Kribel that shows you how has been used the slope graph easily by these comparisons. Very neat. Besides that, we can use the shaded map, uses color to encode quantitative data, example cells by states, or categorical data, example would be region by country. Position is naturally encoded in the map as well. Okay, and this is a symbol map, uses dot or symbols on a map to encode data with position, size, and color, can also be used to encode other data. Tree map also became very popular, especially when we saw COVID, when it hit. Yeah, this was really reused over and over. I will show it in a second. So tree map uses size and often color to encode hierarchical data. It can also be used where there is a very large number of categorical data, a lot of categories to compare that are not hierarchy. So here is example. So this is already available. If you Google just COVID and Tableau, this is a live tracking system day by day, and you can drill in it. This is a dashboard, automatic dashboard. You can see the information available over the web, and the link from down. If you cannot see it, but if you Google it automatically, you will see the link. This is, I just pasted today. Okay. Another type, water chart, uses height and often color to encode data showing and an increase and decrease between time period and or categories. Bubble chart, and I have seen those used in the poster competitions. Some of them I personally do not like, but they started to appear in recent years, so I have to mention them here. So it uses size to encode data, which can be very difficult to interpret for precise quantitative comparison. So for example, here it's hard to see in many cases which circle is bigger and by how much. Another type is Concentric circles uses arc and area to show comparison. They are problematic as well for many reasons. Difficult to make precise quantitative comparison using arc in the area and can distort the comparison of the data. The same here, I would say use them with cautions. And pie charts are as well. Pie charts use angle, so arc and area to show comparison, but they are problematic for many reasons. It is difficult to make precise quantitative comparison using angle, arc, and area. So this can distort the comparison of the data. As we go through examples of pie charts in a couple of slides now, you will notice that it is easy to see 25%, 50%, 75% in a pie chart, but much harder when encoding other values. It is easier to see a single slice in a pie chart or two slices when one is being compared to the other, but the more it is sliced, the more difficult it becomes. So also, I will say a word cloud uses size to encode data, which can be very difficult to interpret for precise quantitative comparison. For example, it's hard to see in many cases which word is bigger and by how much. Just to convince you, here are the rules for pie chart. If you want to use pie chart, if you are not convinced not to use it, you must make sure that it's add up to 100%. And only use few categories. Start at noon and move clockwise, largest to the smallest value. Add labels for percent, avoid 3D pie for sure, and keep it simple. So comparing and contrasting between those charts. So for example, when you are using you have some data and you are asking the question, for example, what is the top 5, what is the second from the top, what is the third, bar charts are the best way to go with. That's the best way. That's it. So there are often some exemptions, so I have to say, like if you want to use pie on top of maps, that's okay. So here are some exemptions, and recent years we have seen those in Tableau and many other applications. Now in Excel, if we try to plot in Excel, this is how the default setting looks like. So we can add data labels to make it a bit more useful, but now we have learned that the pie charts aren't great in comparison, so let us look to the options how we can convert this. So here's in Excel how to convert it. So this is the default bar chart in Excel. So when you have a data and you just select it automatically as a bar chart, this is how it shows it for you as automatically. So notice how the increment of y-x is by default, and the name on the color legend, it says series 1, which isn't useful. So we can clean it a little bit and add data table in Excel. So try to do that, please. Try to add some information, make it cleaner and more useful for your audience to see it. We can also remove the y-axis and add table and label to the bar directly. Okay, that makes it more much easier for the audience. Now we can also rotate the chart, which can be very useful when there are longer labels, so we can avoid rotating text. So you don't want people to tilt their head. This make it really easy to read and make it easy to compare between categories here. This is a different view of the same data. This is called the Pareto chart. Created by Vilfredo Pareto, who was an Italian economist and mathematician. He figured out that 80% of Italian real estate was owned by 20% of the people. Yeah, now we know why he was interested in that. So this is often referred to as Pareto principle of the 80-20. rules. So the chart plot the cumulative percent of with each category, not the number on typical come out exactly 80 to 20 as it did for Pareto, but it can be very useful chart for determining the cause for a problem. In this case, 71% of the occurrence are happening every few months or never. In the tree map of the complaints data, we say 6 companies out of 607 representing 60% of the total companies. Okay. So there are typical 2 ways that people plot Pareto chart. It has to do with the scale of the primary y-axis. In this case, the y-axis plot from 0 to 50%. The advantage of this is that the bars can extend up to the top range of the data, but the line is plotted in the middle of the first bar. Okay, so what else? As alternative, if the y-axis is synchronized, the line extends from the top of the bar chart could be, okay? So however, notice that the bar are now compressed lower to the x-axis. This isn't really a problem with this data, but it could be an issue when there are a number of low value bars that would be difficult to compare in future, okay, if you have data like that. Spark lines, those are really important and you can see them a lot in Excel. We can then place number of them together. You can see interaction between them. You know, they are very useful, especially in small spaces on your poster. So let us go now into the practice section and apply what we learned so far within this workshop. So assume that you have the following table, which is sales by category over time, and you put it in your Excel. Each column represents the months and each row represents category. Here we have 3 categories: consumer, corporate, and education. And I'm asking you the question, which category has the largest sales and which has the smallest? Now, looking at those numbers, you know, it's not big data, but it's really hard to find that quickly. The easiest solution for that is to use something really easy in Excel or in your other applications, the total. So just adding the total will automatically bring this information quickly for you, and the answer would be, you know, right, corporate, then consumer, then education. Very easy, that can give you this information. But if I ask you in which months corporate was not at the top, did it dip by a lot or by little, that's gonna be problematic. But since we have time, we have months here, what you need to think about now, you know, I'm giving you a hint for the answer, to plot this data as timeline analysis. So you move your data into what we call time analysis data, and as you can see now, automatically this information has been revealed to you as line chart. Okay, and you can see immediately from here that the answer to this question would be that the corporate sales had big dip in March, and then you see the education actually moved from 3rd place to the 2nd place in July. So this is how easy can information reveal on your on your presentation. Another thing that I noticed in the poster competitions that a lot of students have a lot of data, so what they try to concise this information, putting them in a cross table or spreadsheet, so to speak. So try to also to summarize or highlight this information in an easy way for the judges to see it. So imagine this data here that I have a profit by region, by subcategories, a lot of data here, but if I want to see the information quickly, like here we have 4 regions and we have about 17 subcategories, so total 68 in total categories. It's very difficult for me to see this information. So the easiest way for couple of seconds just to highlight this table. So now those two color coding, blue and orange, blue which is positive, orange is negative, so we are doing bad in orange. So immediately it pops up like in 3 regions we are not doing well in tables, you know. So that hopefully you can use this information to apply to your cross tables if you are using this type of representation on your posters. But why stop here? We learned other type of pre-attentive attributes to use to your advantage. So just to remind you which ones are the good, which ones are not so good. So if I have data like this, sales by categories, we talked about the bar chart, so it's good to use bar chart, but also make sure to sort them so it will pop up the information quickly for you. Also, I noticed tendency to use this new packed bubbles. So the same information, I presented it here in packed bubbles, comparing both. The same information, sales by categories, bar chart sorted or bubbles. So if you recall, you know, circles are difficult. We cannot really understand how much bigger than the other. If you want to compare, for example, how much the machines are bigger than the phones. We added the numbers here, but you know, it's not so easy to comprehend. So here is another example here for you. So on the left, let me ask you the question. How much is, like if I tell you F is 100, how about G? What is G? What do you think? Write your answer in the chat room. And also on the right side, if I tell you A is 100, how about C? What is the value of C, you think? And when I ask this type of question to my students in the classrooms, most of the time, the question on the right, I will get it correctly. The question on the left, about 40% of the students will answer it correctly. So the correct answer is, not to keep you, you know, puzzled, it's G represent 50. And C, 40. I bet most of you guessed it correctly for the C, and not a lot guessed the G is 50. Our brain is not, you know, used to understand the size of circles. Okay, another thing to, you know, to let you be aware of, always consider the baseline, especially when you are comparing. So if I'm asking you to compare between those 4 location cells, you know, if you don't have baseline, you cannot compare. So all you have to do is just make sure there's a baseline to compare between categories. And this is an example where, you know, be aware of not to make mistake like this. And this was in major news network. So for example, can you spot anything odd to you on this bar chart? So let me put it in this way. So if the bar on the right is 7 million, what is your guess at the bar on the left? I bet you can tell that it is a little less than half. So how can the left bar be 6 million, you know? Because the designer is misleading us. So be on the lookout for things like this. Maybe it's honest mistake, or maybe the chart creator is trying to make something look way worse or maybe better than it is really. It really is. Now it is very okay. You might ask a question: is it ever okay that to have the value axis not start at 0? Absolutely, yes. but probably never with a bar chart. Okay, and that's really, sometimes you will see bar charts on TVs shows you that doesn't start from zero, and they exaggerate the differences between two categories, and that doesn't start and making those differences so big and so huge where it's really small differences. So pay attention to those. Now, there are 5 ways in which color is used in data visualization, either for when you are categorizing, or sequential, or diversion, highlight, or alert. Those are the most known ways. Now, I'll give another example to my students. I split them into two and give one group this chart and ask them, what do you see here about rentals by day of week? Is there something popped up for this company that we should alert them about what's happening with their rentals? And I give the second group exactly the same chart but colored in this way and ask the same question. Then I group them together and tell them, did you spot anything in this data? The first group immediately will tell me, on Saturday and Sunday, the rental is low, while the other group, one or two only, will give me that answer. Not to let them feel bad, the second group, I put the two charts on the board and then show them that that's why the first group was able to find the answer so quickly. So sometimes, yes, colors are good to help us visualize data, but sometimes you overdo it by using more colors than needed. So in this way here, actually colors hurt us, and it didn't help us to get the data. So yeah. Another thing, there are some type of new analysis that we should consider, which is the reference line. Sometimes if you are trying to make your comparison, so let's say sales by store location, and you know the average, so you know now by store location who is doing well and who is doing bad. So for example, the first one, Rio de Janeiro, is popping up so much high. He's doing, more than double than the average of any other store, and now quickly you can see and compare who is doing well, who is doing worse. That's a really good way of getting information quickly. The average line, reference line, correct? Now, also, what else you can do, if you want to make it easier, if you have a goal or objective for each one of them. If you had a goal for each of those, maybe the first one, the location, had a different goal. Maybe it had more customers, maybe it had more, maybe there is, the branch is huge, it has more actually representative there, more employees, so really has to perform better. There are more money were put on that branch, so it's not you're comparing between them. And there was objective, so this line reference that you see in each location, this is the goal, so you're comparing between the goal and between what each location sales reached. So yes, it outperformed, but in comparison to its goal. Okay, and now we have the below, and we have meet or exceeded. Okay, so it's the way you represent the data, and you can use color here, so which is really adding additional value. Also, this is a new way now of representation being popped up in recent years, using very powerful pre-attentive attributes, as you can see here, those little red dots on the left that can automatically represent that those 3 branches we have here, those stores, are really not performing well. Those are the only 3. They are not meeting the goals or the objective we had set for. Okay. Beside that, you can also compare between years, last year and this year. This is a really good way of representation. So if you are doing a research data, you're comparing samples you picked last month and this month, and you're comparing your comparisons. This is a really good comparison of bar charts and comparing single measure but in 2 segments. And you can even put them on top of each other, so maybe over the profit or over comparison between 2 years. Now let us move to the scatter plots. We talked a little bit about it. Here, scatter plots are a really good way of representing a relationship between two measurements. So let's say here we have you are a manager of ice cream parlor, and probably you have a lot of factors that you want to track for your business, maybe including number of customers, how many cups you have versus cones you sold, your inventory, the weather, and many other stuff that you are trying to to analyze your business upon. Suppose you were curious to see if there is a relationship between outside temperature and how much ice cream you sell. Specifically, that's your hypothesis, and you do you sell more on warm days? If so, how much more? Very simple example here, just to to make up a case here. And then you look at the data. So looking at the bottom dot here, you can see that the high temperature was quite cold on February 8th, 35 degree Fahrenheit, and we sold about 15 gallons of ice cream. Compared that to the top dot for July 11, when the high temperature was 78 degree, and we sold 50 gallons of ice cream. It looks like there may be something to our theory, but 3 dots points is not enough to draw a meaningful conclusion, correct? So it looks like maybe there is something to our theory, but 3 dots, as we say, it's not enough. So what we're gonna do, we need to take the whole year. So we took the 365 days worth of data, and we plot the data, and now we can look at it. And in this data, each dot represents a different day, and with exception that there is one dot that's all by itself there. As you can see, on the top left corner, and we're going to talk later about it. But now when we see this data, we talk about what statisticians often call about there is a linear relationship, regression line, or what you call it, a linear regression line could fit in this data, correct? So there is a clear linear relationship between two measures, and we can calculate and plot a linear regression line. I'm not going to go into the particular statistical values in this area, and the R-squared standard error and the p-value over here. This is what you have been covering if your research is related to those type, but it's good to know that you should add those values to your graph if you're using this type of graphs. Okay, but if we are covering the visualization, it's good to mention here that what you are plotting here, that you have the x represent the high temperature, okay, and on the axis, and this is the independent variable, and the y is your dependent variable, and that's the convenience, usually the ice cream. This is your how much ice cream was consumed by gallon. This is your y-axis. Okay, now we might consider plotting it with Tableau or with Excel, you name it, and get a better representation with color coded to make it easier for you to see the data. So in this case, you are determining which is which, so it's pretty easy, as consuming ice cream won't change the temperature outside, but the temperature outside clearly has an impact on the amount of ice cream consumed. Okay, so that's why we are always considering the y is the ice cream. This is your dependent variable. So if you're curious about that outlier over there, there is this is a specific time where we gave actually a free cone day for the people to come and get ice cream. So that's why you see this outlier over there. Okay, even that the temperature was, you know, very low, and but we had a lot of ice cream we sold. Okay, so that explains the outlier. Now, the line chart is to go chart for showing trends over time. We talked about it. Easy, right? So most of the time what you do, old stuff, you put it to the left, new stuff, you put it to the right. There are so many ways to help you understand the relationship between time and other things you might measure. Now here's a chart that shows sales over 4 years period. Okay. Now suppose you want to know which one's sales were particularly good. So we are looking at 4 years period showing monthly sales. So I see this graph here, and I think this is a little noisy chart. So can you tell in which month sales were good? Are there particular months that are good and those that are bad? If you can answer this question, you really have a skill few people have, really, because I cannot get that so quickly. It is hard to group the same months together because they are separated by different years. So what I would suggest when you have a question like this, instead to combine all the January results, February results, etc., and to show the total by month for all those 4 years. And in this way, you can answer a question like that. Okay. There are many charts, so there are many different charts, and of course I cannot cover it in one class. However, in one workshop, I'm gonna give you handouts, two handouts that are really helpful for you to decide when you have any type of analysis you want to do. Will help you to decide what to pick and how to pick. So what is called the graph selection matrix, and will be provided, and a direct link to this to download it through this session. So this chart will tell you automatically when you look at this, if the relationship you are trying to create, so look at the column of this table. Points, is it line, is it bars or boxes? What you are trying to do, what kind of relationship? Is it time series? Is it ranking? So under the feature relation, is it ranking? Is it part of a whole? Is it deviation? Is it distribution? Is it correlation? Is it geospatial? This will tell you what kind of relationship and which type of graph you should consider using, and that will help you pick the correct graph. One workshop will not give you complete overview of what to do with your visualization, but at least give you what to do and what not to do, hopefully. Okay, if you have questions, please email me and I'll be more than happy to guide you in the right directions. Last, the citations, and here is my email if you have any questions.